Hello Year 7. Today we'll be talking about Cumbrian rocks. On the map on the left, you can see that each of the types of rock in Cumbria is shown in a different colour. In orange, here to the west coast, and inland, both at St Bees and in Penrith, you'll find sandstone. Blue denotes or shows limestone. Clint's Quarry and Roa quarries. The grey are our shales. The burgundy purple is Skiddaw slates, where Keswick is. In the green areas, you'll find Borrowdale volcanic series, where Scafell Pike is. And you'll also find granites at Eskdale and Ennerdale. We'll talk more about these throughout this presentation. First, we'll talk about igneous rocks. One way to remember what type of rocks igneous rocks are is Neo. Neo sounds a bit like Nero, and Nero was famously very strong and hard. Okay, so our igneous rocks are our hard rocks. As we go through this video, you'll find each of the slides looks quite similar. We'll have age, strength, density, uses, and cool things about each of the rocks on the right-hand side in a fact file for you. On the left, under this video, in the circle, this will change to show each of the types of rock we're showing at the moment. Our first type of igneous rock is Eskdale granite. As you can see, Eskdale granite has large crystals. Granite is an intrusive igneous rock. Intrusive rocks form from molten material, or magma, that flows and solidifies underground, where magma cools slowly. Eventually, the overlying rocks are removed, or eroded, exposing the granite, shown here. Granite is about 450 million years old. We've given it a strength factor of 9 out of 10, showing that it is very strong. It's quite a dense rock also. It's 2.64 grams per centimetre cubed on average. Many people use granite, because of its toughness, for kitchen work surfaces. And as you can see, one of the really cool things about granite is that it sparkles from the large crystals that are in it. You can see it's sparkling there. The next rock we're going to show you is a Borrowdale volcanic rock. You can see the volcanic ash in Borrowdale volcanic. See here, these different particles of volcanic ash. Borrowdale volcanic is roughly 450 million years old. We've also given it a high strength factor of 8 out of 10 because it is also a very strong igneous rock. It's made from slow cooling above the ground from magma. Again, it's a very dense type of rock, 2.6 on average grams per centimetre cubed. We can use this in landfilling and in construction. Its relative impermeability, meaning water doesn't get into it very easily, of the rock, gives rise to high storm flooding. So the storm flooding in 2009 in Cockermouth, for example, was partly because of the impermeability of this type of rock, Borrowdale volcanic. The water ran quickly over its surface and quickly got to the towns and villages downstream. The next type of rock to show you is pumice. Pumice is created when superheated, highly pressurized rock is violently ejected from a volcano. The foamy nature of pumice, which you can see here in the bubbles, happens because of rapid cooling and rapid depressurization happening at the same time. Pumice is so light at just 0.25 grams per square cube on average that it will actually float. And so in volcanic eruptions at sea, you can get pumice rafts extending tens of kilometers from the volcano across the sea. Pumice is found at many different ages based on the individual eruptions of volcanoes. We've given it a strength factor of 5 out of 10 because whilst it is an igneous rock, it will break much more easily than Borrowdale volcanic or the granite we showed you before. It's got a number of uses, and these include as an exfoliator or it's even used to make stonewash denim, where the roughness of the pumice is used to break down the cotton in the denim. One cool thing, other than the fact that it floats about pumice, is that in Iceland and in a few other volcanically active places, this can be found as still warm. And because it's still cooling above the sedimentary rocks, or S for sedimentary, S for soft rock type. Here under the visualizer, you can see our St. Bees sandstone. As the camera focuses, you'll be able to see the different lines that run through it. These show the different layers as the rock was laid down over time. St. Bees sandstone is about 485 million years old. And with St. Bees sandstone, we find that the sand in this stone and the cliffs at St. Bees are made out of Saharan sand. So when this rock was formed, the sand in it and St. Bees were once where the Sahara is now, 485 million years ago. St. Bees sandstone was created by waterborne sand and has very, very small grain size, making it very workable as a stone. And today we find that it's used in house building. You'll notice many of the houses around this area are made out of this iconic red sandstone that we see here in the St. Bees sandstone. Its strength factor is about 5 out of 10. So whilst it is a softer rock, it's at the harder end of those softer rocks and doesn't break down as easily as some of the ones we're about to show you. Here, in a different type of sandstone, you can also see the lines of the rock being laid down really easily. This is a different type of sandstone. It's not from St. Bees, but again, you can see those lines really clearly. Next up is a Penrith limestone, here under the visualizer now. Penrith limestone is a bit younger compared to many of the rocks we've seen so far. It's only, and I say only, it's only 250 million years old. Limestone is usually grey, or it may be white or yellow or brown in colour. It's a soft rock and is easily scratched. Okay, it easily breaks down and it's permeable. So which means the water gets into it easily. Okay, and it's easily eroded by acids in rain, and we'll talk about acid rain later on in today's lesson. We've given Penrith limestone a strength factor of 4 out of 10. It's not quite as strong as the St. Bees head sandstone, broken down much more easily. As we said, one really cool thing about this is it reacts with acid. If I had some acid here, I'd be able to show you this breaking down. And it's even used in both toothpaste and concrete. Next, we're going to talk about Parton Beach coal. Okay, this is 300 million years old. Okay, it's also a sedimentary rock, and we can see here it's layering. It's been laying down in several layers. These layers are really thin in coal, you'll notice. 300 million years old, laid down in the Carboniferous period. And you'll notice on this piece of paper here, which is currently blank, I can use it to draw and write because it is such a soft rock that it breaks down easily in contact with paper. Okay. It's not as dense as many of the rocks we've seen so far, meaning it's a bit lighter. Okay. It's 1.35 grams per square cube on average. It's got a couple of different uses. We can use it for fuel. We can use it for what's called coking, which is a key part of the heating process in making steel and melting down iron. Okay. One really cool thing about coal is that it is made of decomposed plants, which is really cool. Okay, so this used to be trees and ferns and different grasses, and now it's this carbon heavy type of rock, sedimentary rock, that we can use to burn. Next up, we've got a type of rock that actually isn't found in Cumbria, but we thought it was interesting to show you. Okay, some of you will know this is chalk. okay, and it's kind of iconic in the cliffs at Dover on the south coast of England, okay. It's much younger than the rock types we've seen so far. Again, it's a sedimentary rock. It's only 60 to 100 million years old, but it's a very weak rock. We've given it a factor of 2 out of 10. It is denser than coal at 2.45 grams per square cube on average. And it has a number of uses, okay? It can also be used to draw if I was drawing on something that breaks down less easily. For example, here's our sandstone again, and we can draw easily on that with our chalk because our chalk breaks down so easily. We can use it for a number of things, including raising the pH in soil. Okay, it can be used for drawing, like we just saw, and we can use it for temporary drawing as well because it's easily washed away by water if we use it on an outdoor surface. And one of the really cool things about chalk is that it's made of decomposed marine lime. And now we're going to talk about metamorphic rocks. Okay, so we're going to use the word morph in the middle of our word to remind us that morph means to change from one thing to another thing. And that's exactly what metamorphic rocks have done. They've been used heat and pressure to change from one type of rock, perhaps igneous, perhaps sedimentary, into another. I'm going to show you Skador slate. Okay, so as we look at the Skador slate, we can notice here these clear lines in it, okay? You can see clearly that it looks like it's been laid down, doesn't it? It looks like a sedimentary rock in many ways, yeah, because we've got these good clear layers. In fact, these layers are so thin that it's they're really, really thin, okay? And that means that they can be broken down, it can be split apart really easily into sheets, or slate roof tiles that you've seen on houses, okay? Because if we took the right kind of implement and we knocked this correctly at this end, it would split down these weak lines where it's foliated, okay? And we'd be able to break this apart into sheets to be able to use it. Okay, so roofing is one of its things that it's used for. It is formerly a sedimentary rock, but it's morphed, it's been metamorphosized into this slate, okay? And we can see that here. The heat and the pressure have changed its qualities, but you can still see how the ways it was laid down initially, okay? It is 470 to 485 million years old. It's fairly strong when we consider it this way round, okay? But it doesn't take much of a tap of pressure at the end to split it along its weak lines. So we've given it a strength factor of 6.5 out of 10, which you'll notice is one of the lowest strength factors for such a dense or heavy rock. Okay, 2.7 grams per centimeter cubed on average this, but it does take a long time to break down. It can take, if we use this for roofing, okay, slate roofing, it's definitely fine for a good 100 years on a house roof, despite all the weather and the conditions on that roof. Okay, even when we've taken it down to really thin amounts, it still really holds up to the weather. Okay, and that's our tour of the different types of rock in Cumbria, with the one addition of the Dover chalk. I hope you enjoyed it. Feel free to watch it again and be able to use these images as part of your revision of the different types of rock in Cumbria.